Hello and welcome to this topic, the area of a plane region. According to the definition of a definite integral, we can use definite integral to calculate areas of regions. For simple regions, it's quite easy to write down the correct integral for the area. When we consider more complicated regions, for example, the regions between the two curves, the task of selecting the right integral is more difficult. However, there is a way of thinking that can be very helpful. It goes back to the definition of area and of the definite integral. Here, it is in 5 steps. Now let's see the 5 steps. So the first step is sketch the region, such as this function. Sketch the graph of the function, then sketch the whole region. The second step, slice it into pieces or strips. Label a typical piece. So we slice it into many thin pieces and label a typical piece, such as this blue one. The third, approximate the area of this typical piece as if it were a rectangle. So we'll approximate the area as a rectangle. Step 4. Add up the approximation to the areas of the pieces. So we add up all pieces. Then step 5. Take the limit at the width of the piece approach to 0. The width of each piece approach to 0, thus getting a definite integral. So they are the 5 steps. To illustrate them, we consider a simple example. Example 1. Set up the integral for the area of the region and the curve y is 1 plus square root of x, and between x is 0 and x is 4. Now let's follow these 5 steps. So first, we sketch the graph of the function. Second, we slice it into many pieces. Then, the third one is approximate area of the typical piece, such as this typical piece. We approximate the area like a rectangle. And the fourth step, add up all areas. Then we have this sum. So A is approximately equal to this one. So the last step, we take the limit and we get the definite integral. Once we understand this 5-step procedure, we can abbreviate to 3. That is, first slice, second approximate, then integrate. Think of the word integrate as incorporating 2 steps. First, add the areas of the pieces, and second, take the limit as the piece tends to 0. In this process, the sigma sign transforms to the integral sign as we take the limit. So next figure gives an abbreviated form for the same region. Look at this picture. So first, we slice it. Then, we approximate. So the approximation is 1 plus square root of x times delta x. Then, the third step, take the integral. So the 3 steps is much easier than the 5 steps. All right. Now let's think about the problem of a region between 2 curves. Consider curves y is f of x and y is g of x, with g of x is less than or equal to f of x, like this picture, on the closed interval AB. They determine the region shown in the figure 3. We use the slice, approximate, and integrate method to find its area. So the height here is f minus g, and the width is dx. So the approximation is f of x minus gx times dx. Then we find the definite integral. Be sure to note that f minus g gives the correct height for the thin slice, even when the graph g goes below x axis. In this case, g is negative, So subtracting g is the same as adding positive number. You can check that f minus g also gives the correct height, even when both f and g are negative. Next example. Example 2. Find the area of the region between the curve y is equal to x to the fourth and y is equal to 2x minus x squared. Alright, please take 1 minute to think about it. And who would like to share your ideas about this problem? Alright, Jonathan, could you tell me how to solve this?
Solution. We start by finding where the two curves intersect. To do this, we need to solve 2x minus x squared equals x to the fourth, a fourth-degree equation, which would usually be difficult to solve. However, in this case, x equals 0 and x equals 1 are rather obvious solutions. By sketching the region, we find that the graph of 2x minus x squared is above the graph of x to the fourth. So the approximation of area of the typical piece is 2x minus x squared minus x to the fourth times dx. And the corresponding integral is the definite integral of 2x minus x squared minus x to the fourth on the closed interval 0 to 1. One job remains to evaluate the integral.
That's great. Thank you, Jordanson. Then we solve the definite integral and find the answer. So this definite integral is an integral of 2x minus x squared minus x to the fourth. And it's easy to find the antiderivative. So you plug in the values, then we'll find the final answer is 7/15. Today we discussed a very basic application of integral. But uses of the integral go far beyond that application. We will study them in this whole chapter. That's all for this section. I'm looking forward to seeing you in the next class.